Okay, so how is everyone today?
Good.
Good, I hope. All right, this is college algebra, right?
Yeah.
Okay, good. So I'm the instructor, Dr. Brady McCary. I sent you a couple messages on Blackboard e-learning, so you should have received them to your email. If you didn't receive those messages, then you're either just very recently enrolled and that information hasn't propagated to Blackboard yet, or something's wrong. So, if you think you're supposed to be in here and you didn't enroll yesterday or something, and you didn't receive a message, then you need to figure out why you haven't been receiving those messages. All right. Good. So here's the textbook that we use. I sent a message about it. It's an open source textbook, so you can read the message, the announcement. That means that you can go to the web page that I gave you, and you can download a PDF of this book here. So there's no need for you to get a physical copy of the book unless you just like having physical copies of the books. I'm one such kind of person who prefers to have a physical copy. So if you want to get one, there's a lot of places to get it, but it's not necessary to get one. There is something you do need to pay for, and that's called Webassign. That's we're going to do some assignments there. That's if you haven't had any experience with that before, that's a website that you do homework on, essentially. It costs about $35, so I sent a message about that. The other thing, more or less, that you need, as far as like money's concerned, buying stuff, is you're going to need a scientific calculator. So when we do quizzes and exams, you are allowed to use a scientific calculator. And to be clear what I mean about scientific calculator, so here's an example of one, right? This is the one I'll be using in class. So if you just want to use like the same one that I'm using, it's this kind, TI 30 whatever, that thing. It costs about $15. To the test for whether or not a given calculator is acceptable is basically this, is that it cannot do any symbolic manipulations at all. It can't solve equations. It can't plot anything. It can't do anything like that at all. So basically, it's able to add, subtract, multiply, divide. It's able to do logarithms, sine and cosine, and that's about the extent. Any questions? So that means that like a TI graphing calculator is completely out of the question. Any questions? All right. So the way lecture will go is that it'll be like this. We'll be doing it on the screen there. I'll be writing on sheets of paper like this. And then after the lecture, I'll scan these pages and post them in a place where you can download them, so that's nice. Also, because this is the last college algebra section of the day, I'm recording it with video, and I'll post that too. But don't, I strongly encourage you not to take that as license to just like sit here and watch this like it's like a TV show. So let's be honest about it, okay? So then I suspect that the following statement is true for most of you. College algebra is not that interesting. Okay, I mean we could just be honest with ourselves, right? Okay, so if you're watching something interesting, and you're not like sort of actively, if you're watching something not interesting and you're not like actively engaged in it, you're not retaining anything. So just sitting there watching me do this, you almost might as well, as far as like learning is concerned, you might as well not even be here. Okay, so then I'm just telling you that that's a fact about you, that you might not, you probably know, I hope you know that about yourself, but I'm telling you that you can't just watch something that you're not interested in and expect to get anything out of it. So you really need to be doing something to be actively engaged. All right, so then today's what? The 14th? All right, so then whenever we sort of change to a new topic, like the topic is different than what we were previously talking about, I write this little half box here for REM, which just means I'm making like a new remark. Like you can just sort of scan through the notes and say, oh, that's where something started there. So we're going to talk about the types of assignments that we'll have. So, 0. The first kind is we'll call OHW, which is just means online homework. So 0.0. This is what you'll be doing on Webassign. And there will be one of these per lecture. So, you know, the lectures are numbered. There's a numbering scheme. So, like, here we are right now. This is lecture, and then the number, the designator for this lecture is 00. So, lecture 00, and then the next one would be, so, you know, this is right now. And then we have, you know, the next lecture would be lecture 01. Then lecture 02, right? Dot, dot, dot. So what I mean is that one online homework per lecture is that there is already, in fact, posted an OHW 00. Okay, and it has exercises corresponding to the math that we're eventually going to get to today. It's due more. We'll get to when it's due exactly, but more or less, the OHWs are due basically a week from the lecture. Okay, so then there'll be an OHW 01, an OHW 02, dot, dot, dot. Good. Another kind of thing that we'll have, another kind of assignment, is written homework. Oops. Written homework. So what this is that there are not at the present time any written homeworks posted, but there will be by the end of today. And I'll describe to you where to get them and all of that stuff. But basically, it's you download and print a PDF. You download and print a PDF. It's a math exercise. There's nothing special about it. It's like any other math exercise you've ever done. You work it and you bring to lecture. Okay, there will be 2 or more written homeworks per lecture. And what it is that one exercise is one written homework is one page. So what that means is, like, for written homework, today's, you know, lecture 0, if we assigned, like, say 3 written homeworks for today, that would mean that there would be 3 pages you need to download and print and bring to class. So you bring 3 pages. Okay, so then the way it works, concerning how many, No, there's 2 or more per lecture. So, darn. The correspondence is going to look like this. So for lecture 00, that's where we are now, and lecture 01, ... So corresponding to lecture 00, the names of the written homeworks will be like this. So WHW 00. So the first 2 digits are going to be in agreement with the lecture number, and then the last digit is going to just be a sequence number. So 000 is going to be the name of the first one. WHW 001. WHW 002 would be the next one. WHW 003 would be the next one. ... So as the semester progresses, you might be looking at WHW 23.3, and you would know that oh, well, this is what we covered this material in lecture 23. Okay, so these ones would be something like WHW 01 0, WHW 01 1, etc. All right. So now I'm going to make sure I've got to remind you of some math terminology you already know. And that is, so these are just things you already know. So, there's the number line, right? And then there's that special number that we single out, 0 there. And then the stuff that's to the left of 0, collectively as a group, those numbers are called negative, and the ones that are to the right of 0, those are called positive. So then, the name for this, if I say, what is the blank of 8, and to fill in the blank, if the answer to the question what is the blank of 8, and the answer is positive, then the question is sign, right? What's the sign of 8? Positive. Okay. So you already knew this. So what's the sign of 8? Positive. What's the sign of -4? Negative. 0 doesn't have a sign. Okay, 0 is not negative, and it is also not positive. So that's something you already knew. But the reason why I say this is because there's another thing, another word that is used similarly that you probably don't know. So concerning just these numbers, so 0, 1, 2, 3, 4, ... So concerning just those now. So we can classify those numbers into categories that even and odd, right? So how about 3, even or odd? Odd. 3 is odd. How about 4? Even, right? So this is not new information for you. Okay, so even, odd, blah blah. So this 2, even, good. Even. How about 1? Odd. How about 0? It's even. Which raises the question, what does that even mean? Okay. So just like I could say the question, what is the sign of 8? And you're supposed to respond with positive. Then there's another question that I could say, what is the blank of 3? And you're supposed to say odd. So that word is parity. Parity, not parody, like making fun of something. Parody is making fun of something. Parity is this even and odd concept. So I could say, you know, what's the parity of 80? Even. And what's the parity of 81? Odd. Okay. So you might still be looking at that 0 and saying, you know, I'm not real sure about that. I'm not feeling real comfortable. We're only 5 minutes in and I'm already uncomfortable. All right. So it raises the question, what does even and odd mean? Okay. So imagine that you have, say, 14 identical objects. So they're like identical, maybe like M&Ms. And, you know, they're somehow like really the same, like their mass. And imagine, furthermore, that you've got a balance, you know, a balance, you know what I'm talking about? It's not really proper to call it a scale, because it's not necessarily measuring anything. I'm just talking about a balance, where you can put stuff on one side or the other side, and you can check if stuff's balanced. So you take any number of objects, say 14, then that number of objects is said to be even if it's possible to break those objects. If those objects are all identical, it's possible to break those objects into two groups, and the two groups consist of all the objects, and you put one group on one side of the balance and the other group on the other side of the balance, and the result is balanced. So is it possible to break 14 into two such groups?
Yes.
Yeah, 7 on the one side and 7 on the other side. That's the reason why 14 is even. That's the mathematical reason. Similarly, it's not possible to do that with 13. It's not possible to do that with 13 because if you're supposed to take 13 M&Ms, say, and break them into two groups, and every M&M has to be in a group, none can be left out, then it's not possible to make a result in which the balance is balanced. You can't do it. So 13 is not even, it's odd. So now the question is, what if I give you 0 M&Ms? Is it possible to make two groups, break those 0 M&Ms into two different groups, and the result is balanced? Yeah. The first group can have 0 in it, and the second group can have 0 in it. That's why 0 is even. There's no other reason than that. Okay. So the reason why I mentioned this is that we're going to use these two, in the first place, we're going to use these words a lot this semester, sign and parity. But also, now we can refer to as the written homework as being even or odd. So the evenness or the oddness is the parity of the last digit. So like this one, this is an even one, and this is an odd one. And this is an even one, and this is an odd one. Even, odd, etc. So the reason why we're going to have at least 2 written homeworks due per lecture is because I want there to be at least 1 even one and 1 odd one. That's the reason. Good. Besides online homework and written homework, we're also going to have quizzes. These are going to be in lecture, and the exercises are going to be similar to written homework. And besides that, we're also going to have exams. So there are going to be 2 exams. There's a midterm exam, and there is a final exam. Okay, so concerning the midterm, so you know we're currently meeting for Math 1314 lecture number 002. So that's the lecture section, right? So besides lecture section 002, which you enrolled in, you also enrolled in exam section 701. Now so the meeting pattern for lecture 002 is Monday, Wednesday, Friday at 11. That's when we meet. The meeting pattern for exam section 701, I don't know I forgot what it is, but it's like it's some evening. It's like Friday night at 7 or something, or like Tuesday night. I can't remember. But what we're going to do is we're going to meet once. Is it exam section 701 will meet once. For that exam. I'm waiting for the registrar to tell me when we're going to do that. So, but it's going to be in the middle of the semester, so it's like 7 weeks out, or 8 weeks out. They'll probably let me know on Census Day, which is around next Wednesday, around 9 days from now. So, okay. The final exam, the date is already set. The final exam is May 11th. Now, there's a couple things you need to note about that. So, at the end of every semester, we have an examination window. Sometimes it's called the examination week, but that's really not correct because it's more than a week long. So it's like a window of time in which final exams are supposed to occur. Now, I think the 11th is like the last day, so that's like a bummer. So, you know, we're doing it on the 11th. Also, which is a thing that's not awesome, is that it's a Saturday. And it's at this point that I'd like to point out that I didn't make that choice. The registrar made that choice, and I am about as pleased with it as I imagine you are. But at any rate, that's when we're doing it. Any question about it? It's on Saturday. I forget what time it is. I think it's like at 2 p.m. Fine. Any questions about this? So these are the kinds of assignments we're going to have. Yes?
There's 2 room numbers for the 701. Which one is going to be
the reason why there's 2 room numbers is because there's a bunch of students. It's going to be happening in more than one room at the same time. And when we come to that point, I'll tell you. Yes?
Is the final cumulative?
Yes. Other questions? All right. So this is like the types of assignments. This is the kind of thing that we're going to do. And then the question is what about the schedule? So we just said what we're going to do, and now we're going to say when we're going to do it. And it requires, I find that drawing a diagram of what happens when can be helpful. All right. So day, week. It's a little complicated, but the pattern will become clear shortly. So we meet Monday, Wednesday, Friday. This is week 0. We are in lecture 0, so this is right now. Next one is 01, 02, and then in week 1 we'll have lecture 03, 04, 05, and then in week 02 we'll have lecture 06, 07, 08. So that's enough for now. Now, a lecture is, of course, an interval of time. So we're already a few minutes into this one. So this is 50 minutes. And this is minute 0 on the left and minute 50 on the right there. Good. So every lecture has its interval. All right. So now, if you have a look at the academic calendar, there's a couple different closings, a couple different times when the university is going to be closed. One of them happens to be 7 days from now, because that's Martin Luther King Day. So we're not going to be here. nevertheless, we're still going to refer to that as 03, and that one's still 04, etc. The other closing that is planned is spring break. So that's like in March, but I'm not going to try and write all the way down to March, but it's there. Okay, so now what is due when and where? So this is lecture 00. And as we said on the previous page, corresponding to lecture 0, there's online homework and there's written homework. All right. So this point right here, in between Monday and Wednesday there, this is Tuesday, 11:59 p.m. which is to say 1 minute before Wednesday. At that time is when this online homework is due. Okay, there's no, I mean, in principle you can, but I strongly suggest that you don't wait until the last second. Okay, so that's when it's due. Now, you know, the 0 minute, the 50 minute, the 0th minute, the 50th minute, the beginning, the end of the lecture. So, right here at the beginning of the lecture, beginning of that lecture, that's when written homework 0, 0, the even ones are due. That's when they're due. And at the end there, that's when written homework 0, 0, the odd ones are due. All right. Let's draw the pattern just a little bit further. So again, so this one right here is lecture 01. Here's a point right here. This is Thursday, 11:59 p.m., which is to say 1 minute before Friday. So that's OHW 01 and WHW 01, the evens, WHW 01, the odds. Okay, so now you might say, wow, that seems kind of complicated and overbearing. Okay, I won't even try to dispute that. So, all right, and you might ask, well, why are we doing it that way? Okay, so in the end, here's the reason. It sort of strikes at the heart of, you know, why do we have education at all? And that also basically comes down to, you know, why do we have government at all, right? So then I hope that you're familiar with Leviathan, or just generally, you know, the historical reasons and analysis of why government exists at all. I mean, in the end, the reason why government exists at all, I mean, what a government is just we all get together and say that there's a group of people who have a monopoly on violence. Those are the people who are allowed to be violent. And we all agree that none of us are allowed to be violent. And if any one of us is violent, then that group of people over there is allowed to use violence to stop that person from being violent. That's what a government is. And, you know, the purpose is to encourage flourishing of individuals. Of course, governments and all groups end up taking up other purposes, but whatever. So the purposes of education is basically just exactly this, is that all other things being equal, for an individual or for a society, the more education that there is for that person, or the more educated generally the society is, the better things are. That's the reason why we're all here. That's the reason for it. And furthermore, people who allegedly know what they're talking about say that that math is part of a good education. All right, so I set all those matters aside. So the state of Texas, if you are a citizen of the state of Texas, you get in-state tuition, which means that all the taxpayers of the state of Texas are paying a little bit for you to be here. And because I'm a tax-paying citizen of the state of Texas, that means that even I, diffusely, some extent, pennies or something, I don't know, am paying your tuition. And here's the deal, is that the state of Texas demands all universities report who is attending and who isn't, who's naughty and who's nice. Because if you are signed up for a course but not attending, then you're not going to pay in-state tuition, you're going to pay out-of-state tuition, even if you're a citizen. That's what this is about. So, I basically have to keep really good track of who's here and when and what have you. And the way I'm doing it is I'm making homework assignments. The even-numbered ones due at the beginning and the odd-numbered ones at the end. And if you're not here at the beginning, you can't turn in the even ones. And if you're not here at the end, you can't turn in the odd ones. And honestly, if I had my way, I would just treat y'all like adults, right? I don't really care. I mean, here's the actual truth. I want you to succeed, but here's another truth that's independent of any of that, is that statistically speaking, if you're not here, you're going to fail. It's just that simple. If you're not attending and participating, you are going to fail. And I really believe in freedom, and to that extent, I really would like to treat you as an adult and just say, hey, if you don't want to come, don't come. But the government tells UTD, tells Dr. McCary that this is the way it's going to be. So this is how it's going to be. All right, good? Any questions about it? Fine. So now the pattern continues. We need to draw it a little bit further because there's some other aspects to it. So nothing. So this one's going to be due over here. So now this one you have to be a little bit careful about, because this point that I'm drawing to right here, right there, is Sunday, 11:59 p.m. 1 minute before Monday. Again, you're welcome to wait until the last second and stay up late on a Sunday, but that's more than a week in which you could do that. All right, so there's that. And then, this one is going to go right here. Like that. And then you might think, oh, I'm starting to see the pattern now. And then this one's going to go there, but you'd be wrong. It doesn't go there. It doesn't go there because this day is a quiz day. So it's going to be a quiz. Really, it's kind of like a short exam, really, because we're going to do a quiz, and it's going to be the whole lecture, all 50 minutes. So, yay, we're going to do that there. So, as a result, we need to draw a little bit further. So, week 3, 8, so 0, 9, 1, 0, 1, 1. 0, 4, 1, 1, 2, 1, 3, 1, 4. Okay, so the rule is that the assignments corresponding to a lecture are due at least a week later, as long as we're there. So it can't be on Martin Luther King Day, and as long as it's not a quiz day. So that means that these now need to be connected down there, right? Okay, so let's do that. And you know, you don't need to like diagram this all out. This is all going to be on the calendar. Everything's going to have a due date written on it. I'm just drawing this out so you can sort of conceptually see how everything fits together. That there. So now, that one's not going to be a quiz. And there's no new material there, so there's no assignments corresponding to that lecture, right? So there won't be an online homework corresponding to that, and there won't be a written homework corresponding to that. And so, you know, this pattern continues. So now, so that one there. So now, you know, this one is finally now going straight down to that one, and this one to that one. But this one, this is quiz. So what's happening is that the week numbers. So week 0, that's even. Odd. Even. Odd. Even. So the pattern is that on even numbered weeks, except for this week, we're going to have a quiz on Friday. So why not this week? Well, in the end, because we're just not going to have enough time to talk about stuff. And it's going to be even. It's going to be even Fridays probably until spring break, and then because spring break is a week, you know, we're missing a whole week is missing. It's probably going to shift at that point. So it's going to be more or less like even Fridays before for weeks that are before the break, the spring break, and then probably odd Fridays for weeks that are after. It'll all be real clear on the schedule. Any question about the way stuff works? When is what is due when? Questions about it? All right. So let's do some math then. Finally. All right. So some things we need to know. So sets of numbers. These are numbers. These are things that you need to know by name from now on. So the first is the set of natural numbers. Numbers. It's denoted with this fancy n. So that's an n, but it's written in a little bit fancy way. It's that leg there is like a box, and that's just a stylistic convention that means I'm writing in bold. But you know, I don't have a bold hand or pencil or whatever, and so you know, this is what I mean, bold. So it is this set, the set containing 0, 1, 2, 3, ... That. And then if you wanted to say it in English, you could say it like this. You could say it's the non-negative integers. To which you might reasonably respond and say, non-negative, isn't it easier to say positive? And I would say, it is easier to say positive, but that wouldn't be correct. So why is that not correct? Because of 0, right? 0 isn't positive. Positive integers start at 1. The naturals start at 0. So non-negative, that means positive or 0. All right. So, you know, for example, this could be something like, you know, 1314. That is a natural. But negative 6 is not. Okay. 2. Now the set of integers. integers. So if the natural numbers are denoted with n, then the integers are surely denoted with z, of course. Because that's obvious, right? So 0, positive and negative 1 are in there. Positive and negative 2 are in there. Positive and negative 3 are in there. Dot, dot, dot. So that's all the integers. And you could reasonably say z. Why is the z? In the end, the reason is because when this convention was being set down, 2 centuries ago, in German, it was being set down in German-speaking parts of Europe, and in German, the German word for number is Zahlen. That's Zahlen, like TS kind of sounding. Because in German the Z makes a TS sound, which is why the composer's name is Mozart, not Mozart, because the dude was a German. All right, so -6, that is an integer, yes. But something that's not an integer would be something like I don't know, 3/4, not an integer. All right. Then if we want to name a set that has all of those kinds of things, then those kinds of things are called rationals. And of course, those are denoted with a Q. So fancy Q there. That is equal to the set of all P divided by Q, such that P and Q are in the integers, and Q is not 0. Because you can't divide by 0. So the state of Texas assures me that you're entirely familiar with that kind of notation that I just used there, but maybe not. So I guess the one that you might not know is that. So that vertical bar is pronounced as such that. So all that means, it just means all the numbers where it's possible to write that number as this integer divided by that integer. And the denominator is not 0. So 3/4, yes. How about 5? Okay, if it is, then you have to tell me how to write it as this integer over that integer.
5/1.
Okay, 5/1. Or, a multitude of other ways, right? 25/5, whatever. How about 0.3 with a bar over it? What does that bar mean? Repeating, right? Okay, so how about that?
Not as such.
It can be.
But
Well, yes, how can you represent it as integer over integer?
1/3.
1/3. Okay. How about, okay, so now we've had a few examples that are. How about something that's not rational? Pi. Which, and by that I mean the circle constant, the one that you deal with in trigonometry. So it's not. Now that's kind of a big statement. We're not going to be able to say why that's the case in this class, but I promise you that I'm not lying. That pi is not rational. But I do want to point out that it's sort of like a big statement to say that, because there's like a lot of integers. There's infinitely many of them. And what I'm saying is it's not from those infinitely many, it's not possible to select 2 of them so that pi is equal to this one over that one. We could do it for 0.3 repeating. We found 2 integers, 1 and 3, but you can't do it for pi. All right. So as a little reminder, the primes, those are the naturals, the natural numbers whose divisors are only 1 in itself. So these are little n in the naturals. N has to be more than 1, and the only divisors, only proper divisors, of n are 1 and n. The list of primes, well, the least prime is 2, and then the next 3, 5, 7, 11, 13, ... So 2, 3, and then we skip 4. Why did I skip 4? Yeah, because you can write 4 as 2 times 2. 5, we skip 6 because 6 is 2 times 3. 7 you can't factor, right? So it's prime. Notice that with the exception of the first prime, all of the subsequent primes are odd. Of course they're all odd because any number more than 2 that's even would be divisible by 2. Which is the reason why there's a nice math joke which says that 2 is not an odd prime. It's the oddest prime. Because it shows up all kinds of places. Anyway, it's funny. So the square root, I promise it's funny. So the square root of n, is not rational for every prime. So that means like the square root of 2 is not rational. Neither is the square root of 3. How about the square root of 4? Yeah, it's square root of 4 is 2, right? How about the square root of 6? And now that turns out not to be rational. But the reason is a little tricky. But the square root of any prime is not rational. Finally, the last set of numbers that we need to know by name. We want, it's called the reals. That's the name that we're going to give it. So, and it's denoted with fancy looking R. And what it is that this is equal to, now there's not an easy way for me to write equal to and then write a set. So we don't really have enough math to be able to write down equal and then the set thingy that I want to write. So I'm just going to be a little bit loose here and say this is equal to all the numbers on the number line and there are no gaps. In the sense that the rationals seem to be a lot of the numbers on the number line, but apparently there's gaps, like there's a gap at pi. So pi is not rational, but it is real. And the square root of any prime is not rational, but it is real. And, you know, I can't really say exactly why the name real is chosen, but I will foreshadow. We're going to be able to know next week why it's called the reals. And as a matter of foreshadowing, I want to let you know that the name reals is actually a joke. So every time I say reals, I laugh a little bit inside. And I hope that by the end of next week, you too will have a little chuckle. All right, so have a nice Monday.